Thank you, ma'am.
Okay, we start.
Yeah, recording started, sir.
Okay.
Yeah, I've initiated recording, sir. 1 minute, sir.
Okay.
Sir, shall we start, sir?
Okay. Yeah, we can
Yes.
start.
Good evening to one and all present here. I welcome you all for this webinar on revolutionizing software development, the power of generative AI and agentic systems. I welcome this speaker, Dr. Alpana, Dubey, and all the dignitaries to this webinar. Now I request Mr. H.R. Mohan, Chair Events IEEE CS, to provide the welcome address and also introduce the speaker.
Greetings and good evening to one and all. On behalf of the organizing units, Computer Society of India, IEEE Computer Society, ACM Chennai, let me extend a warm welcome to our today's eminent speaker, Dr. Alpana Dubey, members and my colleagues from the organizing units, and the delegates joining the Google Meet meeting, and those watching the YouTube streaming of today's webinar. The technology landscape has rapidly transformed with the advent of generative AI, the innovation has not only empowered everybody, but also has significantly impacted the way the software systems are built and maintained. Generative AI has introduced several tools and new paradigms in the software development space. Language models, whether large, small, or multimodal, have become essential components of most software systems. Concurrently, new paradigms are emerging for designing software systems. One notable example is the agentic approach to modeling software systems, where agents powered by language models are central to the system design. Software engineers now need a new perspective while designing and developing software systems. The community must also acquire new skills to effectively use modern platforms and tools for building such systems. In our today's presentation, the speaker will present through examples how the technology landscape around Gen AI is being disrupted and how it can be effectively utilized. The speaker will further highlight on how these disruptions would shape the crowdsourcing in the IT industry. The presentation will conclude with a summary of what the future holds for this exciting field. Coming to the formal introduction of the speaker, Dr. Alpana Dubey is the Innovation Research Principal Director at Accenture Labs, Bangalore, leading the Digital Experiences R&D group. Her research focus is on human-computer interactions, artificial intelligence, and software engineering. Dr. Alpana has previously worked at the research labs of ABB, Siemens, and Philips. She is on the board of iHub, DVS Sampark at IIT Roorkee. She is also an ACM India Women Council member. Dr. Alpana has a strong track record of impactful research and development, holds 40 patents, and has published 41 peer-reviewed papers. Dr. Alpana is a senior IEEE member and holds a PhD in computer science from IIT Kanpur. With this brief note on today's presentation and the introduction of the speaker, let me invite Dr. Alpana to enlighten our participants on the topic Revolutionizing Software Development, the Power of Generative AI and Agentic Systems. Over to Dr. Alpana.
Thank you very much, Mohan, for this introduction. I mean, it was really detailed. And hello, everyone, all the audience. It is my absolute pleasure to be talking about this topic on this forum. Thank you, Mohan, for giving me this opportunity. It is absolutely an area which is very, very important in current times, and I think more conversation needs to be done in that space. So in today's talk, I will try to cover some of those, although I would say that it will be tip of the iceberg, but hopefully we will understand that space better. So let me just share my screen. And let me know just if you are able to see it. Can you see my screen?
Yes, ma'am.
Yeah.
And are you able to see the slide share mode, right?
Yes. Yeah, it's fine.
Yeah. So as we heard that the topic of today's webinar is how software development is being revolutionized with generative AI and agentic system. Before I start, I will just want to play a very short video, and we'll understand what is going on in the scene.
I'm going to test you.
Test me.
And please remember while you're taking the test that if you lie, I will know.
Right.
Question 1. What's your favorite color?
Red.
Lie.
Lie?
Yes. Lie.
Then, then what is my favorite color?
I don't know. But it isn't red.
Okay, I get it. I guess, seeing as I'm not 6, I don't really have a favorite color.
Better answer. Question 2. What's your earliest memory?
Well, actually, it's a memory of kindergarten. There was a kid.
Lie.
Really?
Yes.
So I will just
Alright, so
pause
there is-
here, and I'll just give a brief overview of from where this has come from. This is a snippet from a movie called Ex Machina, which has come about a decade ago, in 2014 actually. And this was a concept around how in future the robots will become so advanced, and their ability to converse, understand human, to be another level. So, for example, if you see here that the lady Eva, she is a robot, and she is actually conversing with a human and then trying to understand that whether or not he is telling lie or truth. And as you can see that the conversation is very fluid. She is able to understand from the response that how whether or not that person is saying true truth or he is lying. That was the time when actually the conversational system was not so advanced, and probably it was a time when the people working in the field of AI and NLP aspire to come up with a system which can really understand humans better, in a better way, converse in a very natural way, and then do the reasoning. And yeah, I mean, at that time, it seemed like a very daunting and difficult task. But then in 2017, uh, Google came up with a paper on transformers, which has actually changed the world. I mean, of course, even after that, it took some time, and then we actually started seeing that once we have a big models trained on a lot of data, uh, we can actually come up with a conversational system which are so natural, and so that we cannot really differentiate between whether it is a human is speaking or an AI system is speaking. So this is how in just I would say 1 decade, things have really changed at a very fast pace. And with the introduction of ChatGPT, I would say that things have been moving even at faster rate, and we are actually living the moment of disruption at compressed time scale. And just to give you an idea of what does it really mean, I'll just draw some uh, timeline for the different waves which has happened in Gen AI world, starting from 2015, which was the time when most of the AI researchers were building small models for a very specific task, like okay, image recognition, classification, or intent understanding, sentiment analysis. That was the time. Then it started becoming uh, to scalability. That race to the scalability started, and about 2022, when GPT and ChatGPT was launched, we started seeing that because once the compute gets cheaper, once we are able to actually afford algorithms for large neural network, we can actually achieve a much better performance on different types of conversational task. And now we are actually in 2024 onwards, it has even further improved. So just to give you an idea of even just this small time frame from 2022 to 2025, I have tried to expand only this time duration and what all we have seen in this 2 years or 2.5 years. And the amount of work during this time has been phenomenal. A lot of technologies have emerged, and it has almost become very difficult that to really understand uh, when to expect the next set of interesting technology which is going to change the world. So for example, it started from LLM race in during initial days, if you remember, or if you have followed the news around it. Most of the big tech companies started coming up with their large language models. Then they have started looking at that, oh, okay, this is not enough, text is not enough, and we have to now start understanding more than text. What about videos, images, other modalities? And then rise of multimodal LLMs came up. Then again, what people started slowly realizing that for certain situation, small language models are also sufficient and cost effective and meaningful. Uh, then the rise of autonomous multi-agent system have come, LangChain framework got introduced, and now we have heard the news about the DeepSeek with models, and what we are seeing is that again we are started seeing the same performance with a smaller model or cheaper model, and then that has opened a very new possibility, which makes that even the AI is getting further democratized, and the accessibility to AI is becoming more and more to the masses. So it is becoming utmost importance that how we can leverage different types of AI tools in our daily lives and be more efficient and productive. Now, talking about the software development field itself, uh, this is the timeline diagram for that. And if we see from 2015, this captures a kind of the concept which has created buzz in software industry, especially around the software development. So initially, if you see that it has been around the services, microservices, SaaS, PaaS, all those things. Then in recent time, if you see that more and more advancement is happening around or centered around AI and ML. So it is essentially about increased use of AI or using AI in the software development process to improve the development, thinking about bringing the multimodality, thinking about the safety of AI. So these are some of the important topics which has become quite relevant in software industry to think about it, and that has become more and more prominent in the recent years. So in a way, it is impacting most of the industry. Here I am focusing on software development, and this picture shows that how the AI centered themes are becoming the most important topic. So through this webinar, I would also like you to take a single message forward, which is that we all have to embrace this disruption to our benefits. And we will see how it might be possible and what we should be doing it in next few slides. So this is the just an overview of the webinar today. It is centered around three areas. First one, I will be talking about how is Gen AI shaping the way software is built? How is Gen AI changing software architecture? And what are emerging technologies in Gen AI space? So these are three areas which I will cover. And to start with, I wanted to give a very quick glimpse of generative AI itself. What does it really mean in case, since it's a diverse crowd, uh, uh, for the sake of introduction and make you feel more comfortable, I would spend some time to introduce about this. And before even I start on that, I would really wanted to have these two slides, which are very important considering the increased impact of AI in different fields. And here it is an example of the impact of AI in chemistry. And 2024 Nobel Prize in Chemistry, which was about the protein structure, actually has been given jointly to basically a person from chemistry background as well as the person from computational and AI background. For example, this person in the center, Demis Hassabis, and in the right, John Jumper, they are actually from Google DeepMind, and they have developed AI model to solve a 50-year-old problem on predicting proteins complex structure. And not just that, even the Nobel Prize in Physics has gone, or at least partly gone, to the innovation around AI, artificial neural network. So yeah, so to start with, let's understand what is generative AI in a very layman's term. So in a very layman terms, if I have to explain, generative AI is a capability which is offered by deep neural network, which takes prompt as an input and outputs a response. So that response, prompt as well as the response, which is output, both can be in different modalities. It can be text, image, audio, video, source code means program, and the output can be, you can ask, for example, you might have tried asking ChatGPT to write a story or an essay. Some of you might have even tried to write a program. You might have tried Midjourney to create images, all these. So it's a very generic category in which you take these kinds of inputs and get an output. And the enablers behind that are deep neural network, and some of the names are here. And there are lots of such models are emerging at faster pace. I will also wanted to give you a glimpse of how we can visualize the model which works behind ChatGPT. And this is a small video which I have taken from YouTube, and I would highly recommend that you should actually watch other videos from the same person. Um, uh, he really makes a phenomenal video to explain complex mathematics visually. So I'll just very quickly play for 2 minutes to make you understand what is actually, how does that work. So just 1 minute. I need to just change the audio track. Somehow it automatically takes Hindi. So yeah.
Imagine you happen across a short movie script that describes a scene between a person and their AI assistant. The script has what the person asks the AI, but the AI's response has been torn off. Suppose you also have this powerful magical machine that can take any text and provide a sensible prediction of what word comes next. You could then finish the script by feeding in what you have to the machine, seeing what it would predict to start the AI's answer, and then repeating this over and over with a growing script completing the dialogue. When you interact with a chatbot, this is exactly what's happening. A large language model is a sophisticated mathematical function that predicts what word comes next for any piece of text. Instead of predicting one word with certainty, though, what it does is assign a probability to all possible next words. To build a chatbot, what you do is lay out some text that describes an interaction between a user and a hypothetical AI assistant. You add on whatever the user types in as the first part of that interaction, and then you have the model repeatedly predict the next word that such a hypothetical AI assistant would say in response, and that's what's presented to the user. In doing this, the output tends to look a lot more natural if you allow it to select less likely words along the way at random. So what this means is, even though the model itself is deterministic, a given prompt typically gives a different answer each time it's run. Models learn how to make these predictions by processing an enormous amount of text, typically pulled from the internet. For a standard human to read the amount of text that was used to train GPT-3, for example, if they read nonstop 24/7, it would take over 2,600 years. Larger models since then train on much more. You can think of training a little bit like tuning the dials on a big machine. The way that a language model behaves is entirely determined by these many different continuous values, usually called parameters or weights. Changing those parameters will change the probabilities that the model gives for the next word on a given input. What puts the large in large language model is how they can have hundreds of billions of these parameters. No human ever deliberately sets those parameters. Instead, they begin at random, meaning the model just outputs gibberish, but they're repeatedly refined based on many example pieces of text. One of these training examples could be just a handful of words, or it could be thousands, but in either
So I'll just move on in the interest of time. But as you have seen that
case,
these are basically
imagine
the
you
models which are being trained on the large amount of data, and then the parameters are being set based on how the model is actually outputting its prediction. And if it is wrong, then there is certain process which is called back propagation, which again changes those parameters. Remember the dials of the different dials value. So fundamentally, all the generative AI methods are powered by a neural network behind the scene, but for different types of problems, we may see certain small differences in the way those neural network architectures are used in behind those models. So, for example, here I have put together what are the commonalities and what are the differences. All of them are based out of deep neural network model, and they may borrow concepts from basic fundamental neural network, but in a different way. The difference is that how are they are trained, they processed the different data which when the neural network was being trained. So just to give you an idea or glimpse, these are a very high level abstract way of showing the transformer model, which is behind the scene on ChatGPT. The second model is actually is behind the scene. We can say a model called Palm-E from Google, or there are several models which are based on this. Actually, the leftmost model is called encoder-decoder architecture, and this one is called decoder-only architecture. And when we are talking about the image generation models, for example, you might have used Stable Diffusion or Midjourney and all, right? So they use a very different kind of model of architecture, as you can see in the right hand side. And fundamentally, these blocks, if you see, these are again repeated multiple times. If you see here, it says multiplied by n, and because of those being repeated multiple times, the parameters are increased multifold. So yeah, so this is what is behind the scene. And you might be hearing a lot of different types of the combination of large and model, and I just wanted to give you a glimpse of that. There are different variations which you may hear apart from large language model, which has been traditionally textual. So basically, when you remember the early version of ChatGPT, it used to take text and produce output as a text, but now it also takes, it can take images and all those things. Some models take images also, some models can take some more types of inputs. So now we are also seeing the large models which can process all those things, and there are different variations and the names given. For example, large word model, multimodal large language model, text generation model, large vision model, which actually deals with different types of vision system, like that. So eventually it all actually boils down to a kind of a neural network which may take a very different types of data input and then may produce an output which is also sometimes different. So for example, the models like Palm-E that can interpret natural language and can also generate some robotic instruction. That is one functionality which it offers apart from several other functionalities. So yeah, so that captures the kind of the overall overview of generative AI, and I will move next to dig deeper how generative AI is shaping software engineering. And here I would really spend some time to practically show that how Gen AI can help you in different tasks which is performed during software engineering. So if I have to look at the software engineering process in general, the typical phases which are there is requirements, design, coding, testing, and development. And now generative AI based tool can help in almost all these tasks in a very different ways. And in just couple of moments, I will just show you some of the example scenarios of how to use this in the software development process. And what I will do is that I will actually use the most popular generative AI tool called ChatGPT. I will not go to the other several other tools which are out there, and this field is just blooming like anything, and show that how it can help you to develop simple applications, quick applications very fast. So I'll just uh, change my sharing and share the full screen mode, actually whole desktop. Just give me a minute. Let me know once you're able to see my screen. Is it visible?
Yes, madam.
Yeah. So what I will do now is that, as I was mentioning, just 1 minute, I'll just move to the slide where I left. Yeah. So what I will do is that I will build an application, a very simple loan processing application, and I will just show you how it will work. So once I will just move to this thing, and yeah, so I will just probably show my previous runs rather than starting afresh. So what I did is that I have given this very simple prompt explaining what kind of application I need. So I'm developing a new app and want you to help me on that. My use case is as follows. As a part of loan processing manager, I see application for loan applications. I want to assess the details about customers, his past earning, etc., to give some rating to the customer, whether I should go ahead with the loan or not, etc. So it's a very simple requirement, and there are many things actually in such application. But yeah, to start with, I have just started with this, and then system has actually completely created a system architecture based on that what all I would need, I should be needing in this. If you can see here, system architecture. Then I asked that, can you also create sequence diagram? Generated sequence diagram. It generated UML diagram when I asked that. So all these are the artifacts which are actually used in the software development process. So in order to explain your overall system at a very high level, how does it work? We use sequence diagram, different types of class diagram, systems diagram, all those things. And based on that, this can generate all those things. Likewise, finally, I also asked him to ask the GPT to generate a code. So before that, it gives me a structure that this is how I should be structuring my application, and also showing me some example files which I should start with. In this case, I just told the system that I am using some CSV file just for the sake of simplicity. So it is suggesting me in the CSV format, but obviously for a real application, you would connect it with some database. And then finally, it generates an application, complete application for me. So this application, I have put together everything here, and let me just, I have put together all these outputs, and what I'm going to do is that launch this application. One second, not this one. So this is something which actually one could just do in, I would say, 20-30 minutes. This is the example of that. And of course, while doing this process, you will come across scenarios in which you want to refine it further and add certain more criteria, details, and all those things you can do. So here it is actually working on only 2 CSV examples, which system has suggested, but obviously it is showing me all those things, that what is the risk category of all those. I have also asked the tool to make this evaluation criteria more configurable. So it has also generated this code for this one. Likewise, if you might have seen that it has generated the code for the different types of human diagrams and all those things, which I can use for further generating it at the system level. So for example, for the same application, if I have to explain to someone else that what does it do, I can actually use those generated system diagrams and sequence diagrams to explain all those concepts. So if you can see here, this is the whole system diagram for this particular application which has been generated. So as you can see that all this entire flow has become fairly easy now for anyone to start with, and there are certain good things about it. For example, now you don't need to spend too much of time in documenting all these things, and often what happens earlier that documentation has always been put on the back stage because the teams were all busy in improving the system, fixing the bugs and all those things. And secondly, a lot of time developers used to spend earlier on small issues, small challenges, but with AI, you can actually generative AI, you can focus on the core concepts. You can think about what else I can use, add as a feature and improve upon that. So it can definitely help a lot to make anyone 10x efficient. And all these are actually, I just showed you the example which are from, I have used only ChatGPT and all the available online free tools. You also have lots of options to have these systems in your IDEs, and even you can access all those. So for example, here I am just showing it in the VS Code IDE, and in the right hand side, if you see here, there is GitHub Copilot, which is your pair programmer. So while you are actually working on a project, you can actually ask questions about that. So for example, I can, in this Python notebook, I can select certain part and then ask that what is happening in this. For example, let's say I can ask that, okay, I'm just asking, explain what this code is doing. And the GitHub Copilot will tell me exactly that what exactly is happening in this code. So basically it is helping me to understand the code faster, and also we can use it to add additional code directly while working in the IDEs. So this is one element, and I'll just move back to the presentation. And yeah, so I will now come talk about little bit about publicly hosted LLMs to the local LLM. So when we use chat gpt, right, so we are using a publicly hosted large language model, and all my prompts are going there. But many a times we may not want to use that, and we want to locally have some model, large language model. Of course we cannot afford to have that big language model which chat gpt or cloud and other providers have. But there are decent enough models which can offer a good set of functionalities in multiple scenarios that we can do. So for that we can use tools like Olama, and then we can use tools like Open Web UI, which gives you a very natural feeling of working on a chat GPT type of interface while interacting with a local language model. So I'll just again move to show you some example of it. So here I am already in the um, Open Web UI. And as you can see here, I have just few examples from the previous sessions. What you can do is that you can select here model. So these are some of the models which I have downloaded on my machine and using on my machines, like Llama 3.1, 8 billion parameter. Lava is a vision language model, 7 billion parameter. So right now what you see here as an output in the in this particular text is that it is using a vision language model to explain what is there in this image. So yeah, so uh, what you can do, this gives you a lot of power to uh, test the test the language models locally, how they are performing, and maybe you can create your own benchmark and see that how they are performing on this type of task, uh, whether model A versus model B or the model C, which one is good, and then based on that you can decide to adopt in your application. So yeah, so moving on further, um, these are some of the software engineering tools that have made headlines. But yeah, this is not a comprehensive tool. If I have to talk about different new startups and companies which have come in this space of providing software engineering, Gen AI based software engineering tools, the list is enormous actually. But yeah, you saw a glimpse of GitHub Copilot. But similarly, there is Codium, there is Tab9, Cursor, all those are also pretty decent, good tool which helps in general a software engineer in their overall software development journey. So with this, I move to the third module, which is how generative AI is shaping software systems. So what we saw so far is that how generative AI is helping the developers or software engineers in their journey. Now, there is another type of impact which is happening now, is that how we should be architecting the software system of the future. And I'll just highlight two important impact areas which we are seeing right now. The first one is that there is a transformation towards an agentic paradigm. And the second is that the software stack is revamping a lot with the introduction of Gen AI based or large language model based tool. So when I talk about moving to an agentic paradigm, let me talk about uh, what it is actually. So agentic paradigm is a paradigm where we model entities as an autonomous agent, which is a very different concept which was not uh, there actually by and large. Of course, they have their roots, but by and large those were not there when software were being architected earlier. So just to explain this more concretely, I would just take an example of beehive analogy. So, if you have worked in, let's say, multi-agent system in the past, the concept of multi-agent system is has been there, in which people have envisioned that there are multiple autonomous agents and they have very limited capability, but together they actually perform a bigger and more complex problem, like beehive, like the bees actually do in building the whole hive together. But even though they have a very limited computing power and limited in capacity and all those things. What I would want to add here is that uh, what large language model or the Gen AI has done to this agentic paradigm is that they have made the individual agents more powerful with more memory, more intelligence, better reasoning power, and knowledge. And this is what makes the current movement towards agentic paradigm even more powerful, actually. And we can start thinking about business workflows which are more autonomous and intelligent. So just a very quick intro. So about what the agents are. So agents are autonomous agents, which are AI programs that perceive their environment, understand intention, and take action to achieve their goal. So the language is the new API, which are amplified by the LLM's reasoning capability. And some of the transformative characteristic of autonomous agents are that they are goal oriented, they have a better logical reasoning and planning activities, they have their own long-term memory and reflections, and they have communication capabilities. So think about, I just wanted to bring up this particular picture that think about it as a self-driving kitchen in which each of the chefs are expert in their own task. They know when to respond and what to do, and seek help from others, and then basically work towards the different types of orders which are coming from the customers. And when we think it more in terms of how the businesses see this agentic system, uh, the agentic system is going to redefine how we define the end-to-end workflows. So traditional instruction-driven systems were very, I would say, they were based on very fixed workflows, deterministic application with not much intelligence at each individual entity levels. But when we start reimagining the business workflows as a bunch of AI agents working together autonomously, it brings a lot of intelligence in the system, more contextualization, and more personalization to the end users, actually. So this is what we get as a byproduct of reimagining system as an agentic system versus reimagining the system in a traditional way. So just to help you understand, I have tried to add few examples. So first example is agentic system in financial domain. So just let's imagine that you want an assistant which helps you in actually executing different trades on the trading platform. And for that, there are multiple different activities which require separate expertise, very different kinds of expertise. So there is data analysis expertise, which is required to analyze, which can actually read and crunch lots of data, understand, read the articles, understand the sentiment. You need a trading strategy agent, which takes the input from the data analyst agent, which takes the input from the risk management agent, which is a separate capability altogether, and then defines the trading strategy, what should be the trading strategy. And then finally, all this goes to an execution agent to execute a particular trade. So we can really think about building these agents separately. And eventually, all these agents are actually powered by LLM in the backend, but they are um, they are known to perform certain tasks in a more specialized way. And because of that, this overall orchestration of these agents actually results in a better performance. So another example is agentic system in healthcare. So suppose you want to have a personal healthcare assistant which helps you in your personal journey. So you can probably leverage an agent on patient data analysis. You can leverage an agent which generates a personalized treatment. Of course, treatment is a very important subject which cannot be just given to AI. There is a human in the loop which actually kind of talks to a doctor or medical practitioners and then defines that. Then there is a collaborator agent which helps in orchestrating different types of healthcare providers to provide that type of personalized assistance to you. So moving on, I just wanted to very quickly bring up that the concept of agentic system modeling different autonomous entities working together is not new. And there have been different streams of development uh, over the year. There has been one stream of development which has happened on the distributed systems. There has been one stream of work which has happened around the cognitive architecture. There have been another stream, as we can see, on the neural networks. All those have merged together, and I think that's what has created this modern agentic system concepts. So now I come to the last module, which is about how would software engineering change as a field, actually considering all these development. So now, as we have seen in some of the previous examples, new concepts in software engineering is emerging. A software engineer has a lot of new concepts and new tools in his basket, in his or her basket. For example, he may start thinking about agentic way of problem solving. He may need to understand prompt engineering. Retrieval augmented generation is an important concept, which is very essential when you are building a generative AI-based system. We need to learn the foundational concepts on AI, ML ops, LLM ops. New evaluation metrics are also coming up, which measures the performance of LLM-based system in terms of the latency, answer relevancy. There are a bunch of metrics available from frameworks like Ragas and all. Then observability, how do we observe these systems performance? And finally, how do we test these systems? Because LLMs can fail in a very different modes, and all those things need to be understood. So this whole, this development has given rise to whole new set of topics in the software engineering field itself, which one need to really understand. And when we are thinking about how does it change the technology stack, some of the components have become very important and crucial now in all the AI or LLM-based systems. For example, if you see this layer around the models, you see this layer around the LLM frameworks, you can see the layer around the observability. All these have a lot of new names, which are all related to generative AI and large language model based concept. So given all these development and the newer tools and approaches emerging, what should we continue to nurture and learn? So by showing you all those concepts in the earlier slide, I do not mean that all the existing software engineering concepts are not needed. They are pretty much needed, but in addition to that, we have to start embracing the newer concept, which are absolutely important now in the current times, because uh, generative AI based modules are becoming an integral part in a lot of software systems. But at the same time, we must continue to nurture our ability to problem solving, algorithm development, critical thinking. We should be still developing our ways to optimize the system. We should have a good understanding of security, because all these systems come up with lot of security issues. Responsible AI we must be aware of, because these language models are trained on the web scale data, and the data is not balanced. Distributed system fundamentals we must continue to understand, because what I have observed that agentic systems are still evolving, and there is lot of things which needs to be borrowed from the distributed systems. We should nurture the ability to evaluate code. We saw that code can be generated at a fast pace, but if you get stuck, you should be knowing how to resolve it, and that can only happen once we know the basic programming. AI fundamentals are important, and at the same time, software development lifecycle fundamentals are also important. So yeah, so with this, I just come to the almost the end of this, and I would just wanted to bring a few more points here. What is right now happening in the world? So one is that model context protocol is one of the things which are coming, and it provides a standardized way to connect AI models with different data sources and tools. So what has happened that connecting your system with different uh, data sources was one of the very recurring problem which happens when you write a business application. And now with this, they are trying to provide a standard protocol. We are also seeing a lot of emerging large models like large word models, action models, and all those things, which can cater to a very different types of use cases. For example, robot performing physical tasks, or using these models for in the self-driving cars and all those things. And we are also seeing the increase of the number of modalities on which the foundation models are being trained on. It started with text, then moved from text to text and image, then text, image, videos. Now we may also want to train these models with other types of data, which is maybe a multisensorial data, for example, tactile data, or the temperature and all those things. That will actually enable us to understand or perceive the world better, and then perform certain types of tasks. And these becomes largely very important in the scenarios like robotics applications, and or other types of physical, uh, I would say the AI being used for the physical task. In those types of applications, it becomes very, very important. So yeah, with this, I would just want to close this. I uh, I wanted to close this with a very small set of learning references, and yes, you should be feel free to learn and find out more resources. But some of these which are highly recommended, like the first one, this three blue one brown. This is where you can find a lot of concepts explained visually. So it helps you in understanding the uh, difficult mathematical concept behind these in a much more easier way. So I would definitely recommend, if you want to understand this more. Then there is, if you want to get more hands-on experience, because the first one is more about the conceptual learning. The second one is more about hands-on, in which many times the instructors also share some collab notebook on which you can try your hands-on and then build certain types of tools. And there are lots of short courses available which you can take it, and you can keep yourself abreast with latest happening in LangChain framework. LangChain is one of the popular framework actually for generative AI based system. Others are also evolving, but yeah, overall I think this is a very fast evolving field, so it is always good to keep learning and then understanding what is going on this field. So yeah, so with this I just pause and open the floor for the question. I some questions have been shared already. Let me know if I should be reading those or
Dr. Akila?
Yes, ma'am.
Yeah. Yeah, she will, put the questions to you on behalf of the participants.
okay.
Thank you so much for your wonderful session, ma'am. There are a few questions that has been asked in the chat box. First, let me post those questions, ma'am.
Mhm.
Number one, what is specific impact seen in Edge AI and IoT due to Gen AI?
In IoT, right?
What is specific impact seen in Edge AI and
Edge AI.
IoT due to
Okay.
Gen AI?
So what I would say is that uh, now now there are small language models are emerging. So basically, when we are talking about IoT devices or edge devices, one of the challenge which they face is that they are having limited compute power, limited memory power, and all those things, and therefore people say that we cannot use these large language models for that. But now there is a lot of smaller models are also coming up. There are approaches which help you to reduce the model size called quantization, and so that it can fit on IoT and all those things to perform those types of tasks. So that is where I think, especially when we are talking about edge and IoT, things are happening.
Next question from the same person, Mr. Venkat. Is there a Gen AI tool which can help in HW engineering? For example, a tool to generate system Verilog code for HW.
So hardware engineering.
I have not tried it myself.
Verilog code it is actually.
Verilog programming code.
Yeah.
Yeah, I think it will generate because I have tried it with some non-conventional programming languages also, and it was generating. But it may be of not that good quality if such code is not publicly available too much. But I guess Verilog is a very popular language, so I think it should work well. Yeah. So all these tools also have a different performance on different programming languages. They will be very good on Python and Java because that's where most of the GitHub codes are there, right? So it depends on how much such programs they have seen and trained on.
Thank you, ma'am. And one question from Mr. A. Prakash, Dr. A. Prakash. He has just mentioned it's a simple and fear and repeated question. Will jobs be taken by AI? To get stabilized in the AI field, how can one concentrate?
So I would say that the nature of job may change. In the sense that it will be more AI tool centered. So basically, in most of the jobs, it is inevitable that AI tools will come, but we have to be 10x productive using those AI tools. So I think more than thinking about the job loss, we should be thinking about how we can leverage AI in our job to remain more productive or more productive more than 10x than the previous one. So, for example, in this software world, also a lot of code generation task AI is doing. So you are now able to maybe write better application or produce more application faster. So that is how I see, and I can draw an analogy with the time when factory automation happens, right? The job got redefined. The people who were initially operating the machine were probably started sitting in front of SCADA system or then doing some other types of tasks, right? So it will get redefined, but yeah, it will evolve, I guess.
Thank you, ma'am. A few questions from the time of registration. One question, very interesting question. Uh, how can I learn these generative AI and agentic system technologies as a student who is aspiring to enter into AI and machine learning fields?
So if you are starting from zero, then I would say that you should start first to understand some AI ML fundamentals. There are good courses available on Coursera and deeplearning.ai, uh, which is kind of led by Andrew Ng, who is one of the most known name in this field. So you can first start understanding that, and then one by one, I would say that you should start learning the courses on deeplearning.ai. Uh, and if of course you need to understand some Python, and those Python programming language is mostly used, so you should have a knowledge of Python programming language, and then you can gradually take one courses and then build your expertise. So that's what I would suggest. And most of these courses are actually also um, uh, having some source code examples, working source code examples on Google Colab. So you can really try it out. At the same time, instructors go through each of the source code and explain what is going on. So it gives you a very good idea of how these systems work, and then you can build your newer concept on top of that.
Thank you, ma'am. Next question. Is it a career path to develop AI agents only? How can I optimize the use of agentic AI for a tech startup?
Agentic AI is going to be one of the prominent way of envisioning the software system in the future. That's what I feel actually. And so what it why it is what it is bringing extra, right? So the question is around that. So um, it makes your workflows more dynamic and autonomous and more intelligent. So, as I explained, like in my slides, that uh, agents are autonomous entities and all those things, right? So, it is going to bring more dynamism in the workflows and all those things. Uh, and I see that more and more businesses are going to ask for a transformation journey towards agentic. It may be sounding very similar to how this service oriented architecture transformation journey has started way back. Similar to that, now this is the next type of transformation journey. So any capabilities built in that area will be very useful actually.
Thank you, ma'am. One last question. How generative AI is used for cybersecurity?
Yeah. So you can actually use this to I have not personally used this in cybersecurity type of task, but you can try experimenting with different types of um, threats and all those things. Actually, check with like how we are asking no, ChatGPT to generate code. We can ask ChatGPT to identify the security vulnerabilities. There are coding standards which needs to be followed to ensure the secure coding guidelines and all those things. There again, generative AI can help you to detect all such violations in your code wherever you have, let's say, missed to do a input validation, or wherever your code is having password details in a plain text. All such kind of rules can be specified to the generative AI system, and it can analyze the code and then show you all such violations. So that is one thing which I can imagine. But yeah, there can be other ways also.
Thank you, ma'am. Thank you for your answers for all the questions raised by the audience during the session, and there is in the chat box, and also during the registration. Now, I request Dr. S. Kotishwaran, Chair, IEEE
Yeah.
GS.
Yeah. Yeah. Just can I get one question to speaker?
Yes, sir. Yes, sir. Sorry, sir.
No, sir. No, see, now the people are moving away from large language model to large concept models. Would you like to just give a briefing on these concept models?
Uh, I have not explored this concept model too deeply, so um, I cannot comment more much. But my limited understanding is that these are adding more reasoning capability and symbolic capabilities in the language model, right? So yeah, I mean, uh, I don't have too much of feedback on those actually. I'm sorry.
Yeah, the reason being because that there are a lot of controversy going on in building the language models because of the copyright and other issues, bias and data
Mm,
poisoning and so many other issues. So the people
mm,
slowly they feel that concept models will have a better
mm, mm,
sort of throughput in terms of Gen AI and things like that. I mean, this is what I read from some of the references. So the
mm.
people are they're slowly moving away from the language. I mean, large language models. That's it. I mean, anyhow, it is just a sort of catching up.
Yeah.
So that's what.
Yeah, I mean, symbolic way and the concepts around neuro-symbolic reasoning and all those things are going to generally enhance the capabilities of language model, and probably we are not going to use directly the data, and we store knowledge in the form of concept basically. So
And
that that's why I can say,
that's why the distillation is also taking place. And
yeah,
the deep seek, they did they removed the language modeling. They have sort of one step. They have presumed that it's already existing, and they went ahead with distillation. So that way,
yeah.
the entire cost of learning, has come down. So that is.
Mm, yeah, correct.
So, thank you. Okay,
Thank you,
Akila,
sir.
you can
Yeah,
move on.
thank you, sir. Thank you, ma'am. Now, I request Dr. S. Kotishwaran, Chair, IEEE Madras, to formally propose the vote of thanks.
Thank you, madam. Madam, your session is wonderful. Good evening to everyone. On behalf of CSI Chennai chapter, IEEE CS Madras, and ACM Chennai chapter, I extend my heartfelt gratitude to Dr. Alpana Dubey for her insightful talk on generative AI and agentic systems. Your expertise has truly inspired us. Thank you for joining us. A big thank you to Dr. Mohan sir, Chair, given IEEE CS Dr. K. Komathy madam, Dr. P. Sakthivel sir, Chair, ACM Chennai chapter, for their support in organizing this event. I appreciate all the participants for their engagement and their thoughtful questions, making this session interactive and meaningful. Special thanks to the organizing team and technical support for their efforts in ensuring a smooth webinar. Once again, thank you all for being part of this session. Looking forward to seeing in future events. Have a great evening. Thank you.
Thank you very much for hosting this session, and thanks everyone.
Thank you, Alpana. This was very wonderful.